Hello, welcome to today's video. I thought I'd have a go at a second video in recent times. I know, wild, yet here we are. Today's video is as you can see on the screen, a fun triangle problem that I am going to put forward two solutions for. One using circle theorems and one without using circle theorems. The second way, using circle theorems, is a way I kind of clocked onto by myself, and the first way is the recommended way to solve this problem. So let's get into it. This is from the Junior Maths Challenge UK, from the UK Maths Trust. This was from the 2021 paper, I believe. It says, in the diagram below, PQ equals PR equals QS. Line segments PR and QS are perpendicular to each other. What is the sum of the angles PRQ and PSQ? And it gives you a bunch of options. So the way that is recommended to do this problem is the way I'm going to go through now. So method one, without circle theorems. So what I've done here is that I've taken two triangles from this set. I've taken PQR, which is this triangle here, and I've separated that into this triangle here, and then I've taken the triangle PQS, so we go down, we go up here in this time, and then we go across, and that makes this triangle on this side. So I've separated those two things out. So first thing I'm going to do is use the information in the question. PQ equals PR equals QS. So PQ is this length here, let's just call it A, equals PR, which is this length here, which we're going to call A. And then in the second triangle, PQ is this length here, which we're going to call A, which is the same as QS, which we're going to label and call A. We have two triangles where there are two lengths that are the same. Therefore, these are both isosceles triangles. Imagine that's a good arrow. Both of the triangles labelled are isosceles triangles. So what we can do, let's take this first one and let's just take this angle here, and we're going to label it as alpha. Yeah, we're going to label it as alpha, and because it's an isosceles triangle and the two bottom angles are the same, we're going to label this alpha as well. First thing we're going to do is we're going to go back to this slide. We're going to erase the ink on this slide, and then we're going to say, right, we've labelled this entire thing as alpha. We've also labelled this entire thing as alpha. The question says that PR and QS are perpendicular to each other, so that it kind of labels this angle here as a right angle. Also means that this angle here is a right angle, and this angle here is a right angle. So if we take this bottom triangle here, where Q, the point where PR and QS join, and then R, pretend that's an accurate triangle. So this is a right angle, this is theta, alpha, sorry. Let's just check I'm recording. I'm recording, awesome. So, using the internal angles of a triangle add up to 180, we can say that, right, 180 equals, let's just call this A for now, A plus alpha plus 90. And if you want to solve for A, we take 90 off both sides, you take alpha off both sides, and we can say that alpha is just 90 minus alpha. So this angle here, we're not going to call it A, we're going to call it 90 minus alpha. And then the next thing we're going to do, we're going to go back to here, we're going to, let's go back, yeah, so we're going to call this angle here 90 minus alpha. Now what we want to do, we want to find this angle here. Because we found the angle PQR, which is just theta, which is just alpha, sorry. We found alpha, we found PQR, which is alpha, we found SQR, which is 90 minus alpha, then we're going to find PQS. PQS is this angle here. We don't know what that is yet. However, we do know that these two angles here are both going to be the same. And also we can actually solve for this angle because we know what the total angle is. We know that PQR, so this line goes up to P, R, Q. We know that the whole thing is just alpha. And then we take the line QS, split it into two. We know that this angle is 90 minus alpha. So 90 minus alpha, which is one angle, plus our unknown angle, PQS, equals alpha. So at this point, we just solve for A again. So we take 90 off both sides, we add alpha to both sides. We can say that our angle, PQS, is 2 alpha minus 90. So now we can go back to here and say, actually, do you know what? We do know what this angle is. So we can get rid of our question mark. We can call it 2 alpha minus 90. Now how do we find these two angles here? Well, we know they're the same. So we can say that 2, lots of our question mark, plus 2 alpha minus 90 equals 180 because the interior angles of a triangle add up to 180. Now let's just simplify and solve. Solve for question mark. So let's take 2 alpha minus 90 off both sides. We have to add 90 to both sides. We have to subtract 2 alpha from both sides. So what we're left with is 2 lots of our unknown angle equals 270 minus 2 lots of alpha. Then we just divide by 2 to find our unknown angle, which is 135 minus alpha. So each of these angles are 135 minus alpha, 135 minus alpha. Now at this point, we go back to the question. We say, right, what angles are we actually looking to solve? We're looking to solve PRQ. PRQ. Well, we've got that. We know that's alpha. So we have alpha plus PSQ. PSQ, which is this angle here. Well, we've just found that. We've just found that's 135 minus alpha. So at this point we have alpha plus 135 minus alpha. Now what you might notice here is that the alpha and the minus alpha cancel out, and what we're left with is 135, which is one of our answers. So that's method 1 for solving this, which I thought actually makes a lot of sense, because this is set for, I think, year 7, before circle theorems kind of come into things, but I thought circle theorems was a good way of solving this as well. So that's method 1. Method 2, using circle theorems. So we go back to our angles. Where are my notes for this? They are here. Right, okay, so we have our 2 triangles again. I really should have prepared better for this. So we know that they're both isosceles triangles. We know that we can call this alpha, we can call this alpha, and for now let's just call this beta, and call this beta. We can call this 180 minus 2 alpha. We can call this 180 minus 2 beta. So we're going to take the diagram from the question and we're going to draw a circle around it. Imagine that circle's perfect. Now, there's a rule in circle theorems that says angles in the same segment and standing on the same chord are equal. Now that's a lot of words. What does that mean? It means if you take a circle and you take 2 points on that circle, let's say these two for example, draw a line between them, then let's find 2 random points on the circle other than the 2 that we found. So let's say here and here. And now what we're going to do, we're going to draw a line connecting each pair. So we're going to do a line connecting these 2, and we're going to do a line connecting these 2. What the circle theorem says is that these 2 angles are the same, and these 2 angles are the same. As I have shown here, the 2 angles where the angles of the same colour are the same, because we've gone from 2 points, we've drawn straight lines to 2 different points, and we've done a pair of lines going from these 2 points going to these 2 points. The corresponding angles, because these angles correspond to one another, are equal. So we can go back to here and we can say, right, whatever this is, we're going to call it alpha. Whatever this is, we're going to call it alpha. Whatever this is, we can call it 90 minus alpha. And whatever this is, we're going to call it 90 minus alpha. So at this point, we can label our triangles thusly. We can say, right, we've just shown that PSQ is alpha, and we've shown that PQR is alpha. No, PRQ is alpha. So what we've effectively shown there is that these 2 triangles are identical. They are similar to one another. The angles inside are equal, the lengths are equal. So what we can do at this point, and this little animation is basically saying, right, these are the 2 angles that we're actually looking to find. We're looking to find PRQ, and we're looking to find PSQ. So in this version, we're looking to find alpha plus alpha, which is just 2 alpha. So we're looking for whatever the value of 2 alpha is. And at this point, what we can just do is fill in the gaps. QPR plus RPS equals QPS, which is just these 3 angles here. And we can use that to solve for alpha. We've said here, let's just get the pen back out. We've said that this angle is 180 minus 2 alpha, QPR, I think that should be PQS. Yeah, PQS. 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 So PQS is 180 minus 2 alpha. We've said that RSQR, I've got these letters all horribly wrong, haven't I? In fact, let's just change these letters. So the letters that should be PQS, SQR, PQR. So let's change that. So it should be PQSR. Let's go back to our slide. So let's pretend that never happened. So we've said that this angle here is 180 minus 2 alpha, because we know that this angle is alpha, this angle is alpha, and it's just the internal angles of a triangle. We've also said that SQR, this angle here, is 90 minus alpha, and we know that because this angle is alpha and this angle is 90. So we did that in the last question. And PQR, this whole thing, is just alpha. We said that because it's the opposite angle of the isosceles. So we just plug in the numbers. 180 minus 2 alpha plus 90 minus alpha equals alpha. And now we just have to tidy up. 270 equals 4 alpha. What are we looking for? We're looking for 2 alpha. So we've just halved both sides. 135 equals 2 alpha. That's what we're looking for. We've already said that PRQ plus PSQ is the sum that we're looking for. We've already said that it equals 2 alpha, and now we know that 2 alpha is 135. Therefore, the answer is D. And there you go. There's 2 methods of solving this problem. I hope you enjoyed the video. I thought it was quite a little fun one to do. Sorry that it was just, I was woefully unprepared for it. And I'll see you for another one, hopefully soon.